is the speed of light slowing down? And a possible black hole discovered in the center of our Earth. We meet up with ex-NASA employee Luis Riofrio. She's a scientist that is involved with the implementation of a module, an atomic clock, that will be put into orbit and attached to our space station next year to actually verify her theory. Luis's theory is a game changer that opens up our conception on topics ranging from existence of black holes within the Earth's core to the mathematical potential to achieve time travel. I sit down with Louise to get her incredible explanation in regards to her theory. Is light slowing down?
Well, in school I became interested in connecting the local conditions of special relativity, which don't allow for gravity, with the large-scale universe of general relativity, which hadn't been done before. And I came up with a number of very simple equations which told us everything about the universe that we wanted to know but were afraid to ask, and predicted, opposite to what we learned in school, the speed of light is actually changing over time. And in NASA, in my spare time, I found ways to use the moon to test theories of cosmology. And by looking over the data from lasers bounced off a reflector that astronauts left on the moon, I found hard evidence that the speed of laser light had been slowing over 40 years. This lunar laser ranging experiment is like a bicycle reflector that astronauts left on the moon. By bouncing lasers off it, scientists can determine the moon's distance down to the centimeter. Now, many things change with time. We've known for a long time the moon's distance is increasing due to Earth's tides interacting with the moon. But the laser reflectors said the moon was moving much too fast. And by comparing it with other experiments on Earth, using fossils, using observations of ancient eclipses by international astronomers, and even computer simulation, I found experiments showing that the moon was moving much more slowly. And the difference was the speed of laser light. The speed of laser light slowing had caused the moon to appear to be moving faster, according to the laser. Next year, they're going to launch the world's most accurate atomic clock onto the space station, because in orbit, an atomic clock is more accurate than a clock on Earth, because Earth's gravity won't interfere with the vibration of the little atoms. And this clock will be mounted on the space station. One of its principal science goals is to search for a change in the speed of light. Also, there's a similar experiment going up on a Chinese space station. There will be 2 experiments in space by 2 countries looking for the same thing. There'll be a lot of pressure for them to announce a discovery even before they make it. Now, this is near the edge of our detection, but will they find it? Time will tell.
So if the speed of light is 186,000 miles per second and things are about to slow down, according to your theory, if the speed of light is slowing down, is there any kind of physical thing that we could see on Earth? Are we going to notice anything change, anything different?
Now, about the change in the speed of light, it's very small. In 1 year, barely 1 centimeter per second. Not a lot to affect our lives and day-to-day, but does explain many things, including how our life has evolved on Earth. According to old theories of the sun, the early Earth was too cold for life, and our life wouldn't have existed. But because the sun turns its fuel to energy according to E equals mc squared, if c, the speed of light, had changed in exactly the amount predicted, the sun, billions of years ago, would be nearly as hot as it is today, which has allowed our life to evolve. So if the speed of light hadn't changed, we wouldn't be around to talk about it.
So is there anything in the universe that moves faster than the speed of light?
Well, nothing in nature moves faster than light. That's part of Einstein's relativity that we're able to keep. And this is an improvement over old theories that said that the universe had expanded much faster than light. Yeah, as far as what separates this from previous theories, well, it says the universe is still expanding as we observe. In fact, this math actually predicts it. It actually predicts the Big Bang Theory, not just observing it. And recently some scientists have said that the expansion of the universe is accelerating due to some repulsive dark energy that will eventually cause the planets and even atoms to tear themselves apart. We don't have to worry about that anymore. They forgot something that Martin Luther King said, that darkness cannot drive out darkness, only light can do that. What they were observing wasn't the universe accelerating, but the speed of light slowing down. Now, important nations like China, the US, and Russia realize that science is important. I mean, back in 1905, nobody noticed when Albert Einstein wrote down E equals mc squared, Within 40 years, we had both nuclear reactors and the nuclear weapons. Near the beginning of the universe, the very fabric of space expanded extremely fast, nearly infinitely fast, many times faster than today's speed of light. But gravity, the g, caused it to slow down, and now that the universe is billions of years old, the speed of light is still slowing, but at a very tiny rate. Now, as far as dark matter and dark energy, well, actually they're separate issues. The dark matter would be attractive, and they're searching for it in our galaxy right now. Though this does offer clues to what that dark matter could be. It could be black holes. Now, as far as dark energy, to explain their observations of distant exploding stars, they had to imagine a repulsive anti-gravity force, a dark energy that would eventually tear the whole universe apart. But, thanks to these equations, we don't have to worry about dark energy. It never really existed.
Do you have any people in the science field that disagree with your theory?
Oh, are there people who disagree with this? Oh, yes, of course. Back in Galileo's time, there were scientists who insisted that the Earth was fixed in the center of the universe for all eternity. And yes, today there are people who will teach in school the speed of light is fixed and will never change. And yes, getting over that is, a challenge, but not an obstacle.
So, is time travel possible?
Well, one thing this says is that we can certainly move forward in time, and this also says that the rate that we can move forward in time could be subjective. We could change it. As far as traveling backwards in time, well, if that's ever possible, knowing equations like this will help us find the key to doing that. Well, the idea that time travelers could visit us today, well, that's really beyond our understanding, because time travel would introduce so many paradoxes, such as killing your own grandparents, that we really can't say whether there could be time travelers among us. This theory, this mathematics opens the door to many things. Not just time travel, but the idea of someday warping space to travel faster than light like they do in the science fiction movies. It definitely opens the door to that. And warping space to reach other solar systems faster than light, that is definitely something we may do someday. Now, a lot of us are interested in black holes and their applications. Now, the theory which I independently came up with about a slowing speed of light also tells us things about black holes, that they could be commonplace everywhere in the universe, that a black hole could have caused our planet to have formed in the first place, that a black hole might even be generating the energy that we see in that volcano over there. Oh yes, and yes, just recently, a network called the Event Horizon Telescope actually photographed the silhouette of a black hole. But in the future, we could find black holes lots of places. And to mention just one application, a black hole could be an enormous source of energy. That's something that Stephen Hawking figured out. Someday a black hole could produce immense amounts of energy that could make even nuclear fusion look small. Oh yes, and as far as something that affects our lives every day, turns out while people have looked for black holes in space, there could be a black hole in the last place they would look, beneath their feet, inside the Earth. Don't worry, it would be a very tiny thing, barely the size of a grain of sand, but weighing almost as much as the moon.
So let me actually get this right. So you're actually saying that the Earth is surrounded by a black hole, that there's a black hole within our middle Earth?
Billions of years ago, Earth would have formed around this tiny black hole just as a pearl forms around a grain of sand. That black hole would be responsible for generating Earth's internal heat, which has caused volcanoes and earthquakes, but has also caused our islands to form. And the black hole would also generate the magnetic field, which protects us from the radiation of space. So there's no need to fear black holes. Our life might not exist, or our planet might not exist if not for them, and in the future, they could be an immense source of energy, something as revolutionary as nuclear power was in the last century.
Go ahead.
Well, we're fascinated by CERN, the giant accelerator they built in Europe. And one concern was that it would produce tiny black holes, but don't worry, even if they did produce a tiny black hole, it wouldn't suck us up. In fact, even if there were a black hole on this table, it wouldn't suck us up. And that's just simple mathematics. If you had a tiny black hole, it wouldn't bother you. It would just sink to the bottom of the Earth and join the black hole already there.
So could you quickly demonstrate exactly what you're talking about in regards to the black hole being in the center of Earth and it weighing how much exactly? Go ahead.
Well, as it turns out, While we've looked in space for black holes, a black hole could exist in exactly the last place people would think to look for one, right beneath our feet, inside the Earth. And don't worry, it would be a tiny thing, barely the size of a grain of sand, but weighing nearly as much as the moon.
So a little earlier today, you're explaining to me about you had a theory in regards to how the speed of light is slowing down. Could you share that for us on the wall here?
Oh yes, it's one of the simplest equations ever. It looks like this. Which actually relates to that other famous equation. Turns out, if you know one, you can get the other. This tells you everything about the universe you wanted to know but were afraid to ask. Where G is gravity, M is mass, T is the age of the universe, around 14 billion years, and C is the speed of light. What this says that when T was tiny, C was enormous, and the universe expanded in a bang. Now that T is billions of years, C is continuing to change, but at a very small rate, a rate that's been difficult to detect until now.
Where'd you actually come up with this theory? In your dreams? Were you just crunching the numbers? What happened?
Oh, this just came out of math, which is actually quite inexpensive. All one needs is a pencil and paper. And by doing an awful lot of math, I came to this, which no one had found before.
So you have some critics in the field. What do they got to say about it? Why are they criticizing this theory and sticking with Einstein's theory?
Well, it took years for Einstein's theory of relativity to be accepted. In the case of this, no one had found this before. Getting to this equation was an extraordinary amount of math. And it's going to take a while for other people to understand what this means.
So as we're getting into this theory and what it relates to this possible black hole in the center of Earth, what makes it not suck in the light? Apparently black holes, light can't escape from it. Why is it not happening here?
Well, black holes are known for being black, but as Stephen Hawking showed about 40 years ago, black holes can actually give off radiation, an enormous amount of radiation. A black hole inside the Earth would be responsible for the heat of Earth's core, which causes volcanoes and earthquakes, but also caused our continents and islands to form.
So how hot actually is this?
Oh, many millions of degrees. But don't worry, it's thousands of miles down inside the Earth. But we can feel that heat through volcanoes and earthquakes.
So basically the heat of the planet isn't really have anything to do with the sun, but within the black hole, within the center core of Earth?
Yes, it turns out the planets give off heat of their own. Jupiter, for instance, gives off twice as much heat as it receives from the sun. This could also support a whole subsurface ecosystem of microscopic animals that live inside the Earth feeding off Earth's interior heat.
So you think there's actual life within the center of Earth itself that we're not aware of?
Well, it's been known for a long time that life can exist deep inside the Earth, at least 6 miles. It's possible that life could exist even deeper, which is something for future biologists to discover. Now, as far as applications of this mathematics which I've developed, they're extraordinary. They can change our world as much as Einstein's relativity changed today. It could eventually lead to enormous sources of energy that'll make nuclear power look small, and eventually to travel to other solar systems and allow us to explore the galaxy.
Could there be machines that, you're talking about power that's unprecedented, could anti-gravity be around the corner with this kind of technology, this new theory that you've come up with?
Well, one thing this has led to is a so-called quantum theory of gravity. I call it a quantized theory of gravity, which enables us to understand gravity, eventually to control it.
Do you think our governments around the world have basically found this technology and they're not sharing it with us?
Well, the science I came up with, as far as I know, I invented independently. But when governments look at this, and more than one government's investigating the speed of light, it could lead to many new technologies. Well, this very morning an article came out in a magazine called Room, which is published in Europe. It's a magazine about science and spaceflight, very entertaining. They were going to save their article for this summer, but they thought this is such hot news, it affects so many things, it had to come out now.
So what did they do? Did they agree with your theory? Or how revolutionary is this theory of yours?
Yes, the editor of Room, who happens to be a physicist, was quite excited about it. And she realized it would solve a big problem in science, a so-called tension in measurements of the Hubble constant, which shows how fast the universe is expanding. Well, it turns out the universe has been behaving according to this equation for many billions of years. It's just taken life on Earth this long to figure it out. This is extraordinarily important, the very basic math, the code behind our entire universe.
Do you think there's a possibility that there's some kind of ET out there that have maybe mastered this theory?
Well, since it's possible that other civilizations might have been around millions of years longer than us, perhaps they discovered it long ago and that's what's allowed them to travel the universe. Oh, the book is very enjoyable by anyone for ages 12 and up. It's very easy to read. It starts when a child's eyes open at birth, tells how we learn about the world through our eyes in the first few months, then goes the history of all our discoveries, how we discover that Earth is round, up until the discovery that light itself is slowing down. And there's only one easy equation in the whole book, no math. Oh, this is a very exciting time. They found out that old theories of the Hubble constant don't agree on what the Hubble constant is, which has caused a crisis in science. Turns out that their old theories of the universe are missing something. I would also show how the older theories are the ones that involve repulsive energies and things that can't be detected don't work anymore, and there's room for a big new theory. Well, my theory that predicts that the speed of light is changing over time is gaining more and more followers. I worked with people who are building an atomic clock that will be sent onto the space station, the most accurate clock ever built. In orbit, an atomic clock's more accurate than a clock on Earth because Earth's gravity will not interfere with the vibration of the atoms. And one of its principal science goals is to search for changes in the speed of light. And will it find a change in the speed of light? Well, time will tell.